Hello everyone, in today's video I'm gonna explain the different types of transistors, the nMOS, pMOS and CMOS, and we're gonna see what's each one reaction when we put a high or low voltage in their gates. So as you guys know already, the transistors or the building blocks of the processors, and once you get the transistors you could possibly understand how does a processor works. So let's go ahead. In here we have nMOS. We'll start with the nMOS. We have a gate, we have a drain, and we have a source. In the nMOS you should always remember that the drain is always connected to a high or 5 voltage normally, but in here we would say a high, and the drain of a pMOS is always connected to the mass or the ground. This is the main role. So we are starting here. If you would apply different voltage in the gate, for example, if you would apply 0 volts or 5 volts, okay. So in here we don't count the threshold, and we will talk about the threshold maybe in another video. But in here, if this one being low and this one being high, so when you apply a 0 volt in a nMOS, you would get these connected. No, when you apply a 5 volt, when you apply a 0 volt, you wouldn't connect these. Is it as if you're not connecting it? Think the gate as a switch. So 0 volt or low is a turn off for nMOS. So it would be the voltage or Vs would be 0 volts, okay. And if you would apply a 5 volts in the gate, you would get the VDD, or in here we assume that the VDD is also 5 volts, so low, high. So in nMOS you play you put low, you get low, you put high, you get high, okay. But in pMOS we have a circle in here, and it represents the inversion. So the pMOS is act like an inverter, okay. So if you would apply in pMOS, if you would apply a high or a low, we would start with the low, a low or 0 volts, the outcome would be inverted, or in here 5 volts, okay, or high. And if you would apply a 5 volt or a high, it could be other voltage also, you would get the invert or the opposite of it, or the switch would be turned off. When you turn it on, the current would be turned off, so it would be a 0 volt or low. But in CMOS, which is a combination of a pMOS and an nMOS, it's a little bit different. So in here, if you would see these, we get 0 volt, 5 volt, this represent high, this represent low. So when you apply high, no, sorry, this one is low, this one is low, this one is high. When you apply, let me remove this so you wouldn't get confused. So when you apply low, the pMOS will get activated. So if in here we have a VDD or 5 volts, this one would get activated, and the current would go from VDD to S, okay. So it would be a 5 volt, so, and it would be high. okay? And if you apply like 0 volts, 5 volts in here, this one wouldn't get activated, but this one will, as it's nMOS. So you would connect the outcome with a mass or ground, which equals 0 volts. 0 volts or low. So as you can see, that's actually a NOT gate. So when you create the NOT gate, you could put other transistors together and create OR AND gate, and with the combination of NOT and OR or NOT and AND, you could create any kind of logical gate that you want. But you would say, is this the same as this one? Actually not. I did represent in here with the 5 volt and 0 volt, so you guys would get it. But in here you wouldn't connect the mass directly to the exit, okay? This is just a one way, that's not a NOT gate.